Hey, good afternoon. Greeting audience. This is the ASME Dynamic System Control Division podcast series. I'm a host, Hao Su, from City University of New York.
And I'm the host, Yao Ma, from Texas Tech University.
Today, we are very fortunate to have Dr. O'Malley to join our discussion. For those of us who are from the DSCD community, we are very familiar with her work. For the new audience, how would you like to introduce yourself to our audience?
Well, first, I want to say thank you for the opportunity to talk with you today. I'm looking forward to our conversation. So I'm the Thomas Michael Panos Family Professor in Mechanical Engineering at Rice University. I have complementary appointments in computer science and electrical and computer engineering as well. I direct the Mechatronics and Haptic Interfaces Lab. We call it the MAHI Lab. And I also serve an administrative role at Rice. I work directly with the provost to build collaborative programs, both educational and research programs between Rice and the Texas Medical Center. So we're really fortunate at Rice. Right across the street is the largest medical center in the world, with over 40 institutions and thousands of researchers giving us the opportunity for clinical translation of things happening on the Rice campus. So I try to facilitate those relationships. My own research is in wearable robotics and haptics, physical human robot interaction. And I also not only do I help other faculty build those collaborations with the medical center, I also collaborate and have appointments there. And I do too many other things in terms of professional service as well.
Wow, that's very cool. We are very fortunate to have you join us. Briefly introduce this podcast series. We interview researchers, student leaders, journal editors, and other members of our community to facilitate better communication and build a closer community. By inviting a diverse group to share their stories and insight in a somewhat casual setting, we hope to bring the community closer and inspire good conversation. Yeah, maybe I can start with some question to our guest. You are the program chair for IROS 2020. This was a very unique conference and also a very unique experience for attendees. Could you please share with us how you organized this conference and what you learned in this process?
Sure. So I came on as program chair for IROS 2020 at the time when I could participate in IROS 2019 to sort of learn behind the scenes what the organization was going to be like. And so I started with a trip to Hong Kong in May of 2019, right before things got interesting there, and got to participate in the senior program committee meeting, which was a great opportunity to meet folks who had a lot of experience putting together conference programs. And then I also traveled to Macau in October or November of 2019, one of my last trips, right, to attend IROS 2019. And we were really excited about putting together the IROS 2020 program. So working with Paul O, who is the general chair. But the timeline of the conference is such that like the papers get submitted, the review process happens. My job as program chair really didn't start until May of 2020. And I was supposed to host the senior program committee meeting in Houston, which you know, that we were already in Zoom land then. Right. So we converted a 3-day senior program committee meeting to be a month-long series of Zooms. What was great about this was I was actually able to build a larger and more diverse senior program committee than was typically possible because people didn't have to travel. So people who maybe wouldn't have been willing to come to Houston were able to join Zoom, and we did things in very small chunks. But, you know, I think we lost that sort of networking social aspect that you normally have in those planning meetings. We were really hopeful that we could have an in-person conference, but it became increasingly clear, especially later into the summer, that it wasn't going to happen. But one of the really challenging things with conference organization, especially in the US, it seems to be more of an issue, is you sign these contracts with hotels, and they have these clauses that if you cancel, you don't get your money back. So we were really, we couldn't cancel unless the restrictions around COVID fell inclusive of the dates of the conference. And the way things were happening is shutdowns were like, okay, we're shut down through June. Now we're shut down through August. Now we're shut down through September. And so we were just waiting for the date to creep so that it would encompass the dates of the conference. So that's why we made a relatively late announcement that we were going to switch to a virtual conference so that we didn't have any financial burden. And that then enabled us to make IROS 2020 free. So we decided to do a fully asynchronous conference. It was an on-demand style platform. And I think that was, it worked well for IROS, which is such an international conference, people across so many time zones. We gave up any hope of trying to recreate that like live in-person interaction. But an upside was because we were able to make it free for all attendees, we ended up with over 25,000 registered attendees, and we're able to track how much they were accessing the platform. And most people were engaged for 3 to 4 hours or more over the span of several months that the platform was available. So a different way of doing a conference, a lot of work. But I think in the end, it was a really nice experiment and gives us some ideas about how we can think about going forward in the future. What do we want our conferences to be like, and can we keep some pieces that allow people to participate even if they can't travel?
Is that the largest robotic conference?
Yes.
I think
officially now the largest.
I think it probably breaks the record. A robotic conference history, right? I think that
Exactly. And we got a lot larger participation from industry than we have had in the past, much more participation from Asia than we've had in the past, and from undergraduate students and even some K-12 educators and students as well. So got to expand it to a much bigger audience.
That's truly impressive. And also I can imagine that's really a lot of work from you and other executive, the leadership committee. And thank you for answering this. And also within those research in the past years, can you give us some examples of the significant accomplishment you are very proud of?
Well, I think, when I think about what we've been able to produce out of my lab, our accomplishments sort of fall in two categories for me, the ones that I'm most proud of. I think the first type of accomplishment that really makes me proud is when a student is sort of pushing me in a new direction. So because of their own particular interests or skills or expertise, they start to sort of go to the edges of my comfort zone, and I get to learn about new techniques. So this happened recently with a student who was interested in how we could flip our idea about instead of robots being used to teach or train humans, he really wanted to look at how physical interaction between a human and a robot could be used to teach the robot how we might want the robot to interact. And so we I learned about palm DPs and some other things that I hadn't had exposure to before. So that I'm proud of, because it grew my experience and expertise as well. And I think the second bucket is maybe when a hunch or an idea really finally starts to take hold. So very, very early when I started at Rice, I was interested in how we could use haptic feedback to train new skills. And we tried many things that didn't work. And we kept tweaking and trying, and we like, this has to work somehow. We've got to figure out how this haptic feedback from the robot can be used to train new skills. And we had so many dead ends and things that just never worked. But finally now we're seeing how to do this effectively. And we wouldn't have gotten where we were if it hadn't been for all those missteps along the way. And so I think that just that I've been able to see that idea through to having some success is something I'm proud of.
Cool. I think that's really, really inspiring for us. And also over the years, you have developed a highly regarded research program in mechatronics, haptics, and control. Can you share with us, how do you get interested in those topics at the beginning?
So if you had asked me as a junior undergraduate sitting in ME 375 with Peter Meckel, if I would be doing dynamic systems and controls 20 years later, I would have laughed. It did not click with me at all. I was really, as an undergraduate, interested more in biomedical engineering. They didn't have that major at the time. And so I filled in with some anatomy and physiology classes, and I did undergraduate research with Professor Ben Hilberry, who he had sort of two parts of his research lab. One was developing prosthetic knee implants. So a lot of research on materials and crack propagation in fatigue loading cases, if you can think about, the knee undergoing cyclical loading. And then he had also this 6 degree of freedom knee stimulator that you could put either a cadaver or a prosthetic knee into, and you could do that cyclical loading. And I really got fascinated. I was working with a graduate student who had sort of designed and built the knee simulator. And I was really sort of fascinated about this idea of I could build a machine that could influence human performance. In that case, it was a little bit indirect, right? So this machine was being used to test prosthetics, to make them better designed to help people. So anyway, that's sort of like, when I look back, this idea of designing mechanisms and devices that can affect human performance. I ended up at Vanderbilt University for my graduate studies, and sort of working in the lab I hadn't initially sought out, but Michael Goldfarb reached out to me as a prospective graduate student and told me about some of the research he was interested in that involved physical interactions between robots and humans. And it again sort of captured this really spark in me about this idea of designing devices to improve human performance. So prosthetics and robotics and using robots for training and things like that.
Yeah. I also work on wearable robots. I think this field is very interesting because it's not only research, but also we are building something that can benefit the people, right?
Yeah.
Help people. It's very useful devices. I think, I think I'm also very proud of doing work in this field, and you do, yeah. Really happy for that. Yeah,
it is nice to be able to work with those end users, right? So I think in some ways, while we may be a long way from wearable robots really being out in use, it's important to sort of have those interactions with the end users as part of the research and development process, and it gives us, it helps us sort of see what we are hoping for and to have that impact on their lives.
Yeah. When we talk about the haptics and rehabilitation, what is your vision about those research topics, and what are the open research problems?
Yeah, I think what I really see as exciting right now is how these devices are becoming increasingly wearable and mobile. And part of this is, component technologies, right? So we have new sensors, new actuators, and a push to sort of think about not rigid devices that we wear, like, the exoskeletons in the movie Alien, right? Yeah. But these more compliant soft robots that really can conform to the body. And so I see that as a way to move wearable devices into the mainstream, and out of sort of the intervention only being in a clinic or in a dedicated space or environment. So that's what's exciting to me. And then sort of understanding, the implications of more compliance in our robotic systems makes the control problem much more challenging. So we've got a lot to solve, but well, maybe it's job security for us, right? Always good research challenges.
Yeah. I think it's like a PC, personal computer. It's like a personal robots, right? And it can really portable wearable that you can use in community settings, right? Yeah. And that's very cool. And also, I think recently you are working on some like learning and control research. Could you please share your insight about it? For example, what's the role of AI in robotics?
I think that there's really some great opportunities for AI and machine learning in robotics. But I will say maybe I'm a little bit of a skeptic. Maybe it's not skepticism, right? I think that we should not forego models where we can develop them. So, anything model-based will always improve the performance of our controllers, right? Because we're making better estimates of what the outputs are going to be before we have to sort of correct them with feedback. I think there's certainly a place for AI and machine learning to help us, draw conclusions from very large data sets when a model-based approach is really not tractable. So So some degree of skepticism, but I'm open-minded. But I will say my husband and I got into a fun debate about this when I was, previewing the questions for today. And he said something that I thought was great. So I'm gonna give him credit. He said, don't use AI to teach you physics, right? So when we have expertise, experience, human experience, or an understanding of the underlying physics, we should use that information. And where we need to gain insight because we don't have a model, AI will help us maybe find some patterns that can increase our capabilities of what we can do in those more unknown situations.
Yeah, that's very inspiring. I do think a model really plays an important role. Yeah, there. Yeah, maybe y'all.
I think that's a sentiment that is widely shared in the community. Actually, like we are used to use the model-based approach to develop the control, and so that we will have rigorous performance analysis and how we design those systems. And now it seems like there is advantages of using those data enriched system, but it seems like like you mentioned that the understanding of the system should not use the AI to teach us, or using this black box to teach physics, which has already been there for a couple hundred years.
Right.
I guess that's very widely shared, and also I think it's a very valid points for the research going on in this field.
Yeah, I think it takes some balance, right? It's not gonna be the answer to everything.
Right.
I think I'll say also, I think relevant to our field is that, because AI machine learning is very focused on finding patterns in data, I think there are many applications that we work with that it's the anomaly that we're worried about, right? So if you think about, the behavior of a system, we need to control in the presence of disturbances. We need to be robust, even when the inputs are not known. And those might be circumstances where sort of a pattern based approach that's looking for consistency is not going to be the solution that we need when we need to be able to capture these sort of fringe behaviors as well.
Right. And so speaking of that, actually, I just want to echo back to how earlier mentioned that this podcast actually or the idea of this podcast was initiated last year sometime from XCon. And I think this is, it is motivated by the pandemic because, obviously we have less opportunity to reach out to others, but also we want to, in this kind of podcast series, we not only focus on the research, which probably, you talk about this in most of the seminars and invited speeches.
Right.
Yeah.
But we want to somehow make this like more casual settings, and then we share with the communities what our the normal or normal academia lives during this difficult times. And so other than research, and obviously a lot of things have changed since last year, and specifically for the education and teaching and mentoring. And how are you adapt to those changes? I think this is very challenging for many of us. And can you share with us some of your experience and observations during this?
Certainly. So last spring, I was teaching Introduction to Robotics to about 30 students. And I use a tablet for teaching. And we had to switch to remote. Fortunately, a tablet transitions pretty easily to Zoom. Right. I just share my screen on Zoom instead of projecting it in the classroom. Right. And I think what I'm realizing over the course of the past year is because we had been together as a class for about 2 months before we had to go home, I had those relationships with students already.
All right.
And so they were willing to participate on Zoom. They sort of, we had, a culture of the classroom. And my Intro to Robotics classes is all computational. So they were supposed to do projects. Some of them were able to do some hands-on projects, but it wasn't critical to the class. This past fall, I taught a class very similar to that one I referenced with Peter Meckel. So I teach modeling dynamic systems to juniors, and I had 60 students in the class, and it's supposed to have a hands-on lab component. And this was just not going to be possible. So I videotaped myself, testing first and second order circuits and measuring the inertia of a haptic device. And it lost so much. And, I think the students were willing to be very forgiving. And I got a lot of good feedback. They liked having videos of the labs because they could rewatch them and sort of understand what was important about the lab experiment. But they said, if we were doing this experiment, we would have made mistakes. It would have taken, 3 hours instead of 30 minutes.
Right.
They didn't see all the editing behind the scenes that resulted in a 30-minute lab clip. But so I really felt both of those things: the lack of students being able to do hands-on activities and not having those interactions with students in a classroom to sort of build a culture of the class. I mean, I think it's hard to build that from the beginning on Zoom. So this semester, I'm teaching design of mechatronics systems, which is a very hands-on class. And Rice, fortunately, gave me the ability to, even though we started out teaching on Zoom, I was able to pivot to hybrid in-person / Zoom teaching. And I started that just last week. So I've had 4 classes in person. About 2/3 of the class, so about 40 students, up to 40 students can come in person, and the remainder can be on Zoom. And I see about 20 to 25 so far each day. It has been just such a change to take those little boxes, and then those little boxes of faces are people that you see how they're responding during class. You can tell when they don't understand something. They can interject a question more casually. But even prior to sort of getting back into the classroom, I have a lab space that they can access. And so there's keypad access. We limit we use a Google Calendar, so only 8 of them are in there at a time. But they were able to get in and build DC motors from scratch and see their motors spin. And it really has just emphasized to me, like, we have to be adaptable. But I think it's really hard to replicate that classroom experience on Zoom. And so just having that it's been wonderful to have that back.
Right. And another aspect, in addition to teaching, I think interacting and mentoring for the graduate student is also very essence of our job, right?
Yep.
And I want to ask this question because I remember a few years back when I was a PhD student, and typically as a PhD student, when you are trying to figure out, okay, so I'm going to graduate, where I'm going, what is the career choices, I'm typically you ask for your advisor for suggestions. And I'm just curious, like, you must receive this kind of questions more often than not. And what would your suggestions for your students if they are having this kind of questions or asking for suggestions? Or what are the most valuable things you think they need to think about when they are making those decisions?
So I really try to work individually with students, like recognizing that not everybody wants to follow the path that I followed. We try and make sure that they, if they're interested in industry, can they get some industry experience or internships? If they're interested in academia, can they get some teaching experience? So I would involve them more in like the TA work for my labs. But I also try to encourage them to build their own network and find their community. What's an example? So I have, at this IROS conference, we hosted a tutorial. And so one of my students is working on wearable haptics and like these vibrotactile arrays. And we have a tool that we've developed. And so I really pushed him to organize a tutorial, right, and invite the speakers. And so he's building those relationships. He's building his community. And how do you do that uniquely for each student? I think it's tricky. So, I talk to the students, like I have some that are very much more involved in the ASME, dynamic systems and controls community, right, and others who are much more maybe on the conference on robot learning and right, robotic science and systems. So I try and promote that so that they can be their individual selves, but also, I'm fortunate to have a great network of former students and colleagues and like all over, and to really use those connections to make opportunities for my students.
Right. I think you mentioned that, because each students are obviously different and you provide this individualized suggestions to promote them and basically help them to pursue whatever they prefer. And I think this is particularly important and also very beneficial for individual students. And yeah, and we have one last question I want to ask you about is so can you share with us your recent experience about the selected as the ASME DSC the NYquist lecture last year? Just anything with us, share.
Yeah, I mean, it was a huge honor to be selected as the NYquist lecturer, and I was really some major imposter syndrome as you look back at who have been the other NYquist lecturers, and it's
Oh,
a
yeah.
veritable who's who of DSCD. I remembered Carl Astrom gave the first NYquist lecture. I think it was around 2005 or so, and I remember being there and being kind of curious about this new lecture, and he told this wonderful story about NYquist, and he really personalized it. But you could see just his excitement for the field and his love of sort of explaining concepts and sort of and talking about the contributions that had been made. So I just tried to channel that, and I was really excited to share how much the field of haptics, which is often seen as like, it's a very interdisciplinary field. You think about human perception and rendering and hardware and control, and but it's really governed by fundamental concepts from dynamic systems and controls, and it really grew out of this community. So I had a good time putting together the talk and reflecting on where haptics has come over the past 20 years, and really just sharing those with the community.
Yeah, thanks for that. I mean, as you mentioned, I think the most important thing and also the most inspirational is you mentioned that when you are receiving this honor and the passion and the vision for the field, looking forward, not only by past what we have accomplished, but what we can accomplish within our community and also within the larger areas of the system dynamics.
Yep, absolutely. I think that there's a bunch of unsolved challenges. Some of them go back to the wearables and soft robotics topics that we were mentioning earlier. These design and control challenges where you have the physical interaction of a device on the human. There's all sorts of good dynamics and controls problems in there, and maybe I hope that I entice people to sort of dig into it a little bit more and see what the opportunities are. The field of haptics has in some way drifted a little bit away from its birthplace. And so now the conferences, they are much more interdisciplinary, and there is maybe a smaller portion of it is focused on these fundamental challenges, but they're really, it's going to be overcoming those problems that push haptics forward. So we should invite them back over a little bit more to our space.
Yeah, we are very honored to talk with you today, and also to know many different aspects from researcher, teaching, and many other contribution to this community. We are really fortunate to have you here today. Thanks for your time. Yeah.
Well, I appreciate the opportunity.